This lesson is on section 10.1, the area of rectangles, triangles, and parallelograms. In theory, this should be a review for you, but in case it is not, let's go over some of the confusing parts and some of the pitfalls that students fall into. Perimeter, remember that perimeter is the distance around an object, while area is the amount of space covered by the inside of the object. So how is area different from perimeter? That would be how. Perimeter just goes around the outside. It has nothing to do with the inside. And area just deals with the inside. How are they the same? They both have to do with measurements of the same object. How about the units that we use? For perimeter, perimeter is just length, so we would measure those in single units. While area has to do with the length and the width of an object, so area is in square units. In general, the formula for area is length times width. That's how we get the squared units at the end. Specifically, though, each shape has its own formula. For a rectangle, it simply is the length of the base times the length of the height. That's all that you do. Base times height. And it doesn't matter what order you take them in. The altitude is the line that shows the height. In the case of a rectangle, the length of the side is the height. But in other shapes, it's not. So you have to understand that when they talk about the height of an object, you're looking for the altitude line, the line that shows the height of the object. So for area, you'd simply take the base times the height, and that gives you your area. For a triangle, it's a little bit different. First of all, the formula is 1/2 base times height, and that's because if you were to make a rectangle out of the triangle, the area covered by the triangle would be half of the area of the rectangle. So that's where the half comes from. The area of a triangle formula is 1/2 base times height. Base usually refers to the bottom line. Notice I have bases labeled there. The height would be the altitude line, the line that shows the height of the triangle. It is not usually the side of the triangle. The exception to that is the right triangle. With a right triangle, the other leg shows the height. So for a right triangle, you'll always use the base and the height. You'd do 1/2 base times height. This would show your height. In a regular run-of-the-mill triangle, you would do base, and then this line would represent your height. And in the case of an obtuse triangle, your base is over here. The line that shows your height, your altitude line, would be over here. So 1/2 base times height is how you would do that for an obtuse triangle. Notice they're all 1/2 base times height, 1/2 base times height. In the case of a parallelogram, we do the same thing. It is base times height. The formula is just the length of the base times the height. Notice that in this case, it's different from a rectangle. The height of the parallelogram is different than the side length. Okay? So in the case of a parallelogram, we would do base times height. Make sure you're looking for that altitude line, okay? Not the side length, which is a pitfall that kids fall into. Sometimes you have to turn the shape to get the values that you want. For example, they might give you the height going this way. And in that case, you'd have to take base times height. It doesn't matter, like I said, what order you multiply them in. Just so you know that you have to take a base times a height. You can turn your figure and do it that way, and you can do base times height that way. Okay, so understand that that's a possibility. Some of the problems that you're going to see in your homework are, for example, find the area of this triangle. So since it's a triangle, you're going to do 1/2 base times height. So you have to find the base and the height in the picture. In this case, the base would be 9. That's the bottom of the triangle. The height, when this is the base, the height is 4. So it would be 1/2 times 9 times 4, which gives you 18. And since it's area, it's square units. Notice that they give us the 6. The 6 is the height if this is what we use for our base. Since they don't give us the base, we can't use those values. We have to use the ones that they give us or ones that we can find. In this is a parallelogram, so it's just going to be, oops, my bad. It's just going to be base times height. The height shows us here. So if the height is 5, then we will use 11 for our base. We would simply do 5 times 11, and that would give us 55 square units. An example of a problem in which we have to use the area formula. They give us that the area is 36, but they only give us the length of one of the sides. So in this case, you're going to have to work your formula backwards. B times 4 is what gives you 36. So b times 4 is 36. You have to divide by 4 to get the b alone. The b would have to be 9 feet. Since b is just length, it would just be single units. It would not be square units. In this parallelogram, they try to trick you a little bit. They being me. I give you a base of 5.2. So for a parallelogram, it's just base times height. The problem is that they don't give you the height. They give you the length of the side, but not the height. So you can't use 5.2 as the base. But if you turn it sideways, now you've got a base that's 7.3 and a height of 4.6. So even though they give it to you sideways, that is the way that you're going to want to do it. So you would do 4.6 times 7.3, and that would give you 33.58 square units. Not all the times will the lengths you need just be given to you. You're going to have to rely sometimes on things that you already know. For example, you may need to use the Pythagorean theorem. If they give you a right triangle in which they give you the base and the hypotenuse, you would have to use the Pythagorean theorem to find the height of the triangle if you needed the area. The special right triangle ratios, 30, 60, 90, and 45, 45, 90 triangles. You may need to use those to find lengths of triangles. You may need to use the distance formula. If they give you something on a coordinate grid, you may need to use the distance formula to find the lengths of things you need. Not everything will just be handed to you because we've done so much geometry now that you're going to have to start using some of the stuff that you've learned throughout the year. That concludes this lesson. Your homework is as follows.